This is the tutorial for Chapter 11, Section 5, titled Solving Rational Equations. Let's take a look at our first problem here. And so what we're trying to do is take this rational equation. It's rational because we've got some fractions with variables in there. We're trying to solve for x. And so the best thing to do is you got to come up with a common denominator. And what I would end up doing on this problem is I would go ahead and subtract the 2x, 2 over x, from both sides. And the reason why is that I've got x in the denominator of this other fraction. So what I've got left is 1/2 equals, and since x is in the denominator, I can collect these two terms here, and this makes negative 1 over x. And so when I've got a proportion like this, I can cross multiply. So a ratio set equal to another ratio is called a proportion. And with the proportion, I can go ahead and cross multiply. And so the way I'm going to do that is I'm going to multiply the x by the 1, and that'll give me 1x, and then the 2 by the negative 1, and that'll give me negative 2. So x equals negative 2, and that would be my answer. So on this next one, I end up, and now when we do this, whenever we're solving one of these, you always want to check your solutions. Check to see if negative 2, if this number makes 0 in the denominator. So check to see if the solution makes 0 in the denominator. Now in this problem, it doesn't do it. We just see that negative 2, well, x is the denominator. Now if it was a negative 2 and for x won't change it, but if it was like a x plus 2, well then it would make 0 in the denominator, and that would not be a possible solution. So we'll watch for that. It's not going to happen on these problems here. So let's go ahead, and I'm going to solve this the same way. I'm going to subtract 7 from all sides, and that's going to leave me with 3 over x equals 7 over x minus, or plus 2, because we've got more positives than negatives. So then I'm going to go ahead and subtract the 7 over x from both sides, and that leaves me with a negative 4 over x equals positive 2. I'm going to treat that 2 as a fraction, as 2 over 1. I'm going to cross multiply here, and I'm left with 2x equals negative 4. Negative 4 times by 1. So I divide by 2, and I get negative 2 as the solution. And I check to see negative 2 in for the x will not make 0 in the denominator, so that is my solution. So let's take a look at some other types of problems we'll end up seeing. On this one, we're going to solve by factoring. So this is where we really need to be careful of possible extra answers, extraneous solutions. So here, I can't just move the c term over. I need to come up with a common denominator. So I'm going to treat this as a fraction, and I'm going to multiply this one here by 2, actually this one by, not that one at all. I'm going to multiply the 2 by c over c. So if I do this work here, then I'll have c in the denominator. So it makes it 2c over c minus 4 over c. And see, now I can collect those two together. So I'll keep this as 2 over c minus 2. So when I collect this, this makes 2c minus 4 over c equals 2 over c minus 2. So now I'm ready to go ahead and cross multiply. So I'm going to multiply these two terms. Now this is two binomials, so I've got to use FOIL. Over here I've got 2 times c, so that part's easy. 2c is that work. But on the other side, I have 2c times c, so I'm going to multiply. I'm going to write out what that is. 2c minus 4, and I've got a c minus 2. So I'm using FOIL. So use FOIL when you have two binomials. And so this is going to make a 2c squared, and then minus 4c, minus another 4c plus 8. So these were the first terms, the outside terms, the inner terms, and the last terms there to make this expression. This all equals 2c. So I go ahead and collect some like terms. So I still have that 2c equals 2c squared minus 8c plus 8. And then I'll subtract the 2c from both sides, and that leaves me with this, 2c squared minus 10c. 10 because they're the same sign, so I add, plus 8. And so from this point, I can go ahead and factor this. This is all set equal to 0 because I moved this term over, so I've got it set equal to 0. So I'm going to pull out the 2. Pull out that common factor to make the factoring easier. So I'm just dividing each of the terms by 2, and now I see I can go ahead and factor it to a c minus 4 and a c minus 1. Still have the 2 on the outside. And so now I'm going to take the two factors that matter. The c minus 4, I set that equal to 0, and the c minus 1, and I set that equal to 0. Now I say the factors that matter because they're the ones with c. I'm trying to solve for what c is. So I go ahead and add the 4, and you see I add the 1, and I get the two values that I'll end up seeing here. So c is 4 and 1. But check to see if there's one that does not work. So when I go ahead and substitute these numbers in, 4 in for c here, I end up getting a 2 in the denominator. Here, I end up getting a 4. So it works out. I plug 1 in for c, I get 1 minus 2 makes negative 2, or negative 1, and these both make 1. So it does work out. So these are both good answers because we'll say solutions because the denominators, we'll say the values, because the values do not make 0 in the denominator. Now if they did, one of them did, if it was maybe a c minus 4, then I would have 0 in the denominator, and that would not be a solution. So the next problem is a work problem. And a work problem works this way. I'm going to say job equals rate times by time. It's kind of like the distance formula. Distance equals rate times by time. We're going to use this formula to solve this type of problem. So it says Marion can weed a garden in 3 hours. Robin can weed the same garden in 4 hours. If they work together, how long will it take them to weed the garden? So when they work together, that means the rate is going faster. And that means we're going to add their rates. And so I'm going to go ahead and write this down. We're going to combine their rates. And that's what we're trying to do. So a job completion is 100%. So a job completed represents 100%. Now if I wrote 100% as a decimal, it would just be 1. So basically 1 equals the rate at which one works times by time. So I can find out how fast somebody works when I go ahead and take their time and divide it into 1. And so I'm going to take a look at Marion. So Marion's rate, we're trying to find that out after 3 hours. So if I divide by 3, notice that Marion's rate is 1/3. So basically what that means is 1/3 of the job is done each hour. 1/3 of the job is done after 1 hour. So that's the rate at which she works. So the rate ends up being the reciprocal of the time. We're going to see that with the next person, Robin. So Robin, a job completion is 1. That's the job being done. Her rate times by time. So if I divide by 4, notice Robin's rate, the rate she works is 1/4. So 1/4 of the job is done each hour. Each hour. So 1/4 of the job done each hour. So you're going to end up being done after 4/4, after 4 hours. And that's what it says here. So basically what we're going to do is we're going to take these rates, the 1/3 and the 1/4, and we're going to combine them together because we want to see how fast they work. So let's try this. So together what we're going to do is we're going to take 1, and that's the job completed, and we're going to take their rates. So 1/3 plus 1/4, and we're going to add those together and multiply by time. We don't know how long it takes, but we do know how fast each of them works. So I need to add these two fractions. So off to the side, I'm going to do 1/3 plus 1/4. So I need to multiply this fraction by 3/3, this one by 4/4. And I multiply across, gives me 4/12, and 3/12 makes 7/12. So they get 7 parts of the job done out of 12 parts every hour. And so that's what their rate is. So 7 parts out of 12 parts each hour. So multiplying by time equals 1. Well, to solve for time, I'm just going to multiply by the reciprocal. So I'm going to multiply by 12 over 7. And that's going to cancel out the 12s and the 7, do the same thing on this side, and we've got the answer. 12 sevenths equals the time. Well, we just do some division. 7 into 12 goes 1 time with 5 left over. So writing that a little neater. 7, and I subtract, I get 5 left over. So that's going to be 1 5/7 hours is how many hours it's going to take them to finish the job if they work together. So those are the problems that you're going to end up seeing on today's assignment. Good luck.